Hey guys, this is Mr. Grice for Algebra Unit 10.4 Notes. Today we're talking about analyzing residuals of linear correlations. Our learning target today is to be able to analyze the residual of linear correlations. So, before we get started, we got a lot of definitions and stuff to do. So, the correlation coefficient that measures the strength and direction of a linear correlation relationship. Okay? The key thing to know in the calculators is that it is going to be the variable r. Okay? So a graphing calculator can give us the exact value of a correlation coefficient. Now, the way to do that, let me show you. Let me pull up my graphing calculator. Hopefully you guys got yours in front of you or you're taking good notes so you can follow along when you have to do this yourself. So what I'm going to do is I'm going to hit the second button and then I'm going to hit 0, which is the bottom left. And it brings up the catalog. Okay? So what we need to do is we're going to use our arrows to find the diagnostics. Okay? And these are all in alphabetical order. So we're going to be going down for a little bit. Let's see, am I there yet? Okay, almost there. So I keep looking, I keep looking, I keep looking. Okay, so there is diagnostic on. That's what we want to click, okay? So we're going to press the enter button and then I'm going to hit enter again. So now it's on, okay? Let's go back to the notes. So we've done all that and you just want to make sure that you go to diagnostic on and that's where you hit enter and then enter. Okay. Now we can calculate a linear regression. The correlation coefficient will automatically appear. So I'm going to plug this data in myself just to make sure I get it. Okay. So I'm going to go to stat, edit. And this is where you guys can pause the video and you can do this all on your own. You can make the graph too. Okay, so here's the graph that they got. If you look at my window, that's all the information I have on my window. And then if you want to see just making sure that you plugged in the data, there's all of the data you should be using. And there we go. So we need to find the equation. So to find the equation, we hit stat, calculate its linear regression. So we're down to number 4. And then we hit enter again for calculate. And there we go. And my screen looks exactly like it is on the notes. So our equation, we have to round to the nearest 10th, or the 100th, I'm sorry, if possible, because that's what the directions tell us to do. Our equation would be y equals 1.3x plus 4.5. Now, our relation coefficient, that's what r is. And r is right here. And that's where we want to round, okay? So when I round this, that's going to be 0.86. All right, so our relation coefficient, or correlation coefficient, I'm sorry, is 0.86. And what does that tell me? Well, it tells me that that correlation is strong and it's positive. Okay, and pretty much looking at your graph, wouldn't you say the same thing, that it's strong and positive? Yeah, that's what that letter's telling us. So the coefficient of determination, that's the r squared. That's the second variable that it's talking about, okay? And that measures the percent of data that fit the equation. So if R2, I'll zoom out a little bit so we can see everything. If R2 is close to 1, then the equation is a good fit for the data. This means that the data, what we're talking about is the residuals are small. So of the data above, that's where we're going to take that percent right there. It's telling us that 74% of the points fit the equation. Okay? So all we did is we took this number all right here, and that's what we're talking about. Okay? Now, let's keep going. Residual is the vertical distance between a point on the line of best fit and a data point. Okay? So we're looking at the vertical distance. It's either going to be a positive distance or it's going to be a negative distance. And the actual value is the given y value in the data. Okay, that's on our table. The predicted value is we have to calculate that from the line of best fit. Okay, so the key thing today is just learning the data. Okay, so to find the residual on the other side now is we take the actual data, which is the given value, and we're going to subtract the predicted y value, which is the calculated from the equation. Okay, so they already gave us the graph, so we don't have to worry about finding all that stuff out. However, we do need to figure out what the equation is. Okay, so let's go into our calculator and plug in all that data. And you don't need me here to do that, so go ahead and pause the video. Okay, so the only thing that mattered was the data. Now that we've got the data, it's starting to ask us questions. What is the exact correlation coefficient? So we need to go to stat, calculate, and it's linear regression. And let's graph it. Okay, so what's the correlation coefficient? That's what R is. And remember, we want to round it to the 100th, which is the second decimal. Okay, so it's going to be R equals 0.89. So 0.89. Okay, so what's that tell us? We're describing that correlation, and it tells us that the correlation is positive and strong. So positively strong. What is the coefficient of correlation? Well, what's the R squared? Okay, that is 0.78 rounded. So we're going to write that this is 0.78. And now it wants to know the percent, so we're going to take that number and we're going to times it by 100. And that gives us that 78% of the data fit the equation. Okay? So, what do you think? We good so far? Now, the next part, D, it says find the equation of the line of best fit. Round to the nearest hundredth. So using this data, what's our line? What's the equation? You should be writing y equals 1.77x plus 0.8. And the key thing is we rounded to the nearest hundredth. All right, so now on to the next part. It says calculate and analyze the residuals of the data. So the first part tells me what x is and then the actual y value. So to get that, I'm just going to come up here. So for 6, my y value is 12. So I just come down here and the actual y value, 12. To find the predicted value, we're going to plug in y equals 1.77 plus 0.8. And we're going to plug in 6. And now that's just plugging into your calculator. Okay, and what do you get? We get that y equals 11.42. So that's our new information that we need. And what are we going to do with that? The residual is the y minus y with that little funny thing on top of it. Okay? What that's telling us to do is that we take the actual minus the predicted. All right, so I'm taking 12, which we found before, and I am subtracting 11.42. And what number do you get? We get the number 0.58. Okay? So that actual value, is that more or less than the predicted one? It's more. Or is that number more or less to begin with? Okay. Since it's a positive number, it is more than predicted. Okay. So let's take a look at our first point that they told us, 612, where x is 6. We get that it is more than predicted. Okay. Let's do another one. Let's do 5. 5, and the partner for 5 is 8. So we're going to plug in 8, and we're going to do the same thing. Y equals 1.77. We're plugging in the number 5. Oh, let's do a different color so we know that's what we're plugging in. Plus 0.8. What did you guys get? Did you guys get 9.65? That's what I got. Okay, so what we're going to do, same thing. 8 minus the 9.65. And what value do you get? Well, I got negative 1.65. And that is less. That actual value is less than predicted. Okay, so your graph, it should be less. And now if we look, sorry guys, I was kind of going through this real quick, but here's 6. See how that value is positive, it's higher. And then we just did 5, which would be right here, and we just said that it's less. That's all we're talking about. How close are those points to the line of best fit? All right, so for number 4, the actual value was 10. Okay, so we're going to plug in 4 and tell me what you get. Okay, you guys should have gotten 7.88. The reason why I'm not showing you this work in a calculator because you're just plugging it in. All right, and when we go to do the work, we're doing 10 minus the number we just found, okay? The 7.88. And you should be able to tell right now if that's more or less. You get 2.12. And that answer is more. Okay? Now, what I want you to do is pause the video, do 3, 2, and 1. You can do those all on your own. All right? Good luck. Remember that you're plugging into y equals 1.77, plugging in plus 0.8. Okay? Okay, and there's all of that data. Okay, now when you're looking at it, we had 1, 2, 3 that were more and 3 that were less. If we look at our graph, there's our line. We had 1, 2, 3 points above and 1, 2, 3 points below. Okay, that's where that comes from. You can look at your graph even when you're doing it on the graphing calculator. You can see how I drew the line too. I can tell that there are 3 points above and 3 points below. Okay, now I'm not going to sit here and go through all this stuff because this is just basic calculation, but if you need help, please come see Ms. Carranza or myself. Now, 10.4 is your homework, the 10.4 practice. Okay, they tell you the equations in here. All right, so all you're doing is plugging in the information. You do not need a graphing calculator for it. Okay? All right, well, this is Mr. Grice signing off for Algebra Unit 10.4 Notes. Thanks for watching.